Here's problem number 1814. Two identical strings have the same length and the same mass per unit length. String B is stretched with 4 times as great a tension as that applied to string A. Which statement is correct for all n harmonics of the two strings? Well, our relationship for the harmonics of a string to the length and velocity of travel of those waves is that the nth harmonic is equal to n divided by 2L times the velocity of waves on the string. Now we happen to know that the velocity of waves on a string is actually the square root of the tension divided by the mass per length. So that would be our frequency of the nth harmonic in general. So in this case, the frequency of the nth harmonic for string A is going to be equal to n over 2L times the square root of the tension in string A over the mass per length of string A. And the frequency of the nth harmonic for string B is going to equal n over 2L times the square root of the tension in string B to that of the mass per length of string B. Now, if we were to take the ratio of these two, so if I were to divide the left-hand side and divide the right-hand side, we would get the ratio of these two frequencies, the frequency of the harmonics in A to the frequency of the harmonics in B. And then this n over 2L would cancel out, and we do have the same mass per unit length for both strings. So the square root of 1 over the mass per length will cancel out on both sides. So we'll have that this is equal to the square root of the tension in A to the tension in B. I can write this then as the ratio of the frequencies in A to the ratio of the frequencies in B is equal to, now we have the square root of the tension in A to the square root of the tension in B, but we're told that B is stretched 4 times the greatest tension as that applied to A. So this would be equal to the tension in A, and the tension in B is 4 times the tension in A, all this square root. So the tension in A cancels out. This would be the square root of 1/4, which is 1/2. So I would have that 2 times the frequency in A is equal to the frequency of the nth frequency in B. So the for all n harmonics, so the nth harmonic of B will always be twice the nth harmonic in A.